Hi students, in this video we are going to discuss priority queue data structure. So what is this priority queue? So you know queue data structure. There are different types of queue data structure. So one is simple queues or linear queues. Simple queues or linear queues. Second one is circular queue. Third one is DQ data structure, double-ended queue data structure, and then priority queue data structure. What is this priority queue? All these already I discussed in previous videos. Simple queue, circular queue, DQ data structure. Now we are going to discuss this priority queue. What is this priority queue data structure? Generally, queue data structure means first in, first out. So we discussed applications also. So like scheduling algorithms, routing algorithms, ticket reservation counters, all these things are applications of queue data structure. That also we discussed. So now, what is this priority queue? Priority queue means the operations are performed based on priority. Based on priority. That means for each and every number, for each and every element, priority is assigned. For each and every number, priority is assigned. Based on that, the operation is performed. For example, here I want to perform 4 operations. Process 1, process 2, process 3, process 4. Okay. So then in generally queue data structure, scheduling is first in, first out. First in, first out means first P1 is came. So first P1 is performed. Next P2 came. So P2 is performed. Next P3 came. So P3 is performed. And then P4. So like that. So 4 processes are processed or completed their tasks based on first in, first out manner. But it is not possible, or the requirement may be different based on our application. That means, for example, the priority of first process is 3. Priority of second process is 1. So this is 2. This is 4. So first priority I am giving to P2. That means here lowest number represents, my assumption, it is my assumption, lowest number represents highest priority. Lowest number represents highest priority. Lowest number represents highest priority. In that situation, first which process is completed? So P2 will be completed first. After that, next highest priority is for P3. So P3 will be completed first. After that P1 and after that P4. This is the order of completion of the processes if you are considering the priorities. If you are not considering the priorities, these are processes just based on FIFO manner. Our assumption is the lowest number represents the highest priority. Like that, if you want to perform the processes or operations based on the priorities, then this priority queue data structure is used. Okay, so now how can we represent this priority queues? Diagrammatic representation, here it is. Diagrammatic representation of priority queues is, see, generally this is a simple queue. I am representing it as a simple queue or linear queue. So here we are performing insertion operation, which is called as NQ operation. So here it is insert and here it is called as delete. Okay. So whereas this is a simple queue. This is simple queue. Whereas in priority queue, the diagrammatic representation is, so this is insertion. Insertion is done in the given order, but deletion is done based on the priority. That is the difference. Delete min or delete max. So insertion is, so in what order it is coming, in that order only that element is inserted. But deletion operation is performed based on the priorities. Based on the priority. If you are representing lowest number as the highest priority, then insertion and delete min operations are performed. If you are giving highest number as the highest priority, then insertion in the same order, whatever the order, in what order it is coming, in that order, and then delete max. Okay, so in here you are getting like in ascending order of priority queue. This is ascending order of priority. Why? Because first which one we are deleting? We are deleting the smallest number. So ascending order you will get. Here which element we are deleting? Maximum element. That maximum element we will place in the last position. No. So that's why. So here first we are deleting maximum. That means here you will get descending order of priority queue. Descending order of priority queue. Like that, the operations performed on priority queues are insertion and delete min or delete max. That is diagrammatic representation. Now, how in the computer memory these priority queues are represented? Representation of priority queues in computer memory. Representation of priority queues in computer memory. So there are mainly used, as you know, by using arrays. And another representation here, it is tree representation. Of course, linked list representation is also there. Okay, so now we are going to discuss in this video arrays representation and tree representation. So by using arrays, how these elements are represented. For example, the priorities are like this: 10, 5, 3, 2, 18 are there. Now, how the array is represented in priority queue? If it is a simple queue, you can write like this is 10, 5, 3, 2, 18. This is present at rear end, and or here front is present here in -1th position. Like that in simple queues. The elements are represented in simple queues. Now in priority queues, how the elements are represented. So first element is 10. Yeah, you can represent. Now here we are assuming that the smallest number is having highest priority. Smallest number is highest priority. Smallest number is highest priority. Okay. So now see here you can insert 10, 5, 3, 2, 18. So in what order you are inserted, in what order the elements are coming, in that order you can insert. Okay. But deletion. So how can you perform deletion operation? You can perform only delete min. Why? Because the smallest number is having highest priority. So which one I had to delete? This number I have to delete. Whereas in simple queues, 10 we can delete. Why? Because first in first order. But now, so priority based queue here we are discussing. So lowest number represents highest priority. This is the highest priority. So what I have to do? Delete min operation I have to perform. That means I will get an array after deleting 2, 10, 5, 3, and here it is empty 18. But now what shall we do? This 18 we should move to this position. So then 10, 5, 3, 18 is the array. Okay, so this is the first deletion. Suppose another deletion I am going to perform. Another deletion I want to perform. Then what shall we do? Next smallest element is this one. See what we have done? Insertion in whatever the order the elements are coming, in that order we have inserted. Now delete min operation, how can we perform? Delete min operation means we have to find out the smallest element, and after that again what we have to do? We have to move that right side elements to left side. So now again, now the elements are 10, 5, 18, and here you have deleted element 3. Okay, so but it is not a correct array na? So we will shift 18. So then your array is 10, 5, 18. Now another delete min, if you want to perform, you can delete 5. Like that you can perform delete min operations using arrays or in arrays representation. Or another way of representing the arrays, here it is, take another one, the same set of elements like this, 10, 5, 3, 2, 18. Same set of elements here I considered. But while performing insertion operation, what I am doing is, in ascending order I will insert. That means first here it is 10. Okay, that is inserted. Next you got 5. Then 5 and 10 are compared. As 5 is lesser, that means 5 is a small number, but it is having highest priority. That should be placed at the beginning. Then what shall we do? From here what we will get? So from here we will get 5, 10 and remaining places are like this. From here. So 10 completed, 5 completed. Next one is 3. Next element is here, it is 3. So 3 is the highest priority. Why? Because our assumption is the lowest number represents highest priority. So here 3. So 3 you have to represent at the beginning. So here you will get 3, 5, 10 like this. Next 2. So now here it is 2. So then 2, 3, 5, 10 and the next elements. Next number is 18. So 18, highest number represents lowest priority. So 18 here you can insert. Then 2, 3, 5, 10 and then 18. So what is this? This is ascending order of priority queue. Ascending order of priority queue. That means a small to large or the small number to big number. So this represents highest priority. This is one way of representing. Okay. Similarly, you can represent a descending order of priority in the same manner. You can represent descending order of priority means here the highest number represents lowest, highest number represents highest priority only. Okay. So that means, so now you can represent like this. I am considering same elements 10, 5, 3, 2, 18. So now what is our assumption? Here assumption is smallest number highest priority, and here highest number is highest priority only. Highest number is highest priority. So that means consider an array. Now first number is 10, so remaining are empty. Some elements are there, 10. Next element is 5. So next element is 5. Of course, this is lowest priority than compared to this 5. So you can insert. Next 3 and 5. This is lowest priority. Then 3 and 5. 3 is lowest priority, then here you can insert. And the next one is 2. 2 is lowest priority than 10, than 5, than 3. So you can insert. Next one is 18. 18 and 10. See, the highest number represents the highest priority. So the array is 18, 10, 5, 3, 2. What is this? This is called as descending order of priority, Q. Descending order of priority, Q. Okay. So now in this way you can represent a priority queue data structure. So first way is in whatever the order the elements are coming, in that order we have inserted. Second way is ascending order of priority queue. Third way is descending order of priority queue using arrays. Now second representation is using trees. Using trees, how these priority queues are represented. Using trees, the priority queues are represented like a binary heap. Like a binary heap. So binary heap means that may be min heap or max heap. Min heap or max heap. Min heap means it is a tree representation. No, tree means the tree is like this. Especially here I am saying binary tree representation or binary heap. That means maximum how many children a node can have? Maximum 2 children a node can have. So min heap means parent is less than its children. Parent is less than children. So max heap means parent is greater than its children. Parent is greater than its children. Okay. So now this is min heap and this is max heap. So now what diagrammatic representations of this tree data structure. So what is this binary heap? Binary heap is a complete binary tree. So that's what here min heap. A complete binary tree with min heap, complete binary tree with max heap. Either min heap or max heap is called as a binary heap. So binary heap is a complete binary tree in which it may be represented in the form of min heap or max heap. What are these? That I have explained here. Now, what is diagrammatic representation of min heap? Parent is less than its children. So 1, 2, 3, 4, 5. See, 2, 3 parent is 1, 4, 5 parent is 2. For example, here it is 6. 6 parent is 3, which is less. So this is min heap. That means, see, what is this min heap? Min heap is nothing but, so lowest number represents highest priority. Lowest number is highest priority. So what we will do here? We will perform the operation delete min operation. Okay. So now this is min heap. Now coming to max heap. What is max heap? Parent is greater than its children. Like 10, for example 8, 9, some 4, 3, here it is 2 and 1. What happened here? This parent is greater than 8, 9. 10 is greater than 8 and 9. 8 is greater than 4 and 3. 9 is greater than 2 and 1. So parent is greater than its children. It is max heap. So what is this one? This maximum number represents highest priority. Maximum number represents highest priority. So that means what we will do here? We will perform delete max operation. So in priority queue, what are the operations we are performing? Insertion, delete min or delete max operations. In this way, the Priority queue is represented using arrays and linked list. Hope you understand, students. If you have any doubt, you please send me a message in the comment box. If you like the video, please share with your friends and subscribe the channel. Thank you, students. Have a great day. Bye.